This idea of a keynote on HTTP2 actually arrived when I saw a talk on, well, this very topic at a conference in Switzerland last year by our dear Simone here. And I figured, like, how relevant can a standardization effort really be? And well, HTTP2 is about as relevant as it can be. We are all working with HTTP on a daily basis. Whatever we do in any domain, as a user, as a developer, we're confronted with HTTP and we rely on it doing an efficient job for us. And I really liked that twist in the particular talk that we're about to see, that the value that HTTP2 can bring is really, it's more in the nuances, in the efficiency of our runtime infrastructure behind all of our web applications. So embracing this new revision of the HTTP standard is really, well, a challenge and a responsibility for all of us. We need to make sure that our infrastructure, our applications, our clients are all up to the latest and greatest in HTTP2. Well, we're going to hear about the details in just a bit. It's your stage, Simone. Thanks.
Yeah. Okay. Thank you for coming. This is going to be like a story that I'm going to tell you, and it's a travel in the past and then back to the future of how the HTTP protocol has actually changed over these years. As Jürgen said, the HTTP protocol is probably the most successful application protocol that has ever been written. So it's really important that we get the clear idea of what's going on. So this is what this session is about. So let me start with this page. Now, this one is the page of the w3c.org in 1996. It's 20 years ago now. And it was a single HTML file and 600 bytes. I mean, it's not kilobytes or something, it's 600 bytes. So the key thing here is that 1996 was also the year where the HTTP 1.1 protocol was designed and put out as a standard. Okay, so the HTTP 1.1 protocol was designed to serve these pages. Now, fast forward to 2015 or 2016, this is the same page of the w3c.org. It's now 41 resources for 366 kilobytes. Now, this time it's one HTML file, 4 CSS, 2 JavaScript, and 34 images. So it's bigger. But the key thing is that this page is not even close to the average page of the internet today. This one is the CNN.com page. Well, this page is a whopping 95 resources for 6.7 megabytes of download for 3 HTML, 4 CSS, 30 JavaScript files, and 58 images, okay? And if any of you was at the previous session on HTTP performance, I was stunned by the numbers that those guys put out, because they put out some 20 megabytes pages for 400 resources download here. So the web has exploded. And HTTP 1.1 is a very old protocol. It's an efficient protocol for today's web. There's no multiplexing, there is no resource correlation, all things that we need in today's web. And web developers have started hacking around limitations. So hands up, who here knows about domain sharding, for example? Okay, a bunch of you. How many of you do image spriting? Okay, a little bit more. So these are considered best practices. However, they're not. They're actually hack around the HTTP 1.1 limitations. Okay? But the problem is that we're stuck with HTTP 1.1, so we have to implement those hacks and those workarounds in order to get HTTP 1.1 web applications performant. So browser vendors want to make browser really fast. There's a war between Chrome and Firefox and Internet Explorer, now Edge and stuff, in order to make the browser fast as possible and faster than the competition, right? So the HB11 specification said, well, you can only open 2 connections to a single domain. But the browser vendors quickly realized, well, but if I only open 2, and I have to download 95 resources, what happens? That I open 2 connections, make 2 requests, wait for them to come back, then make another 2 requests, and wait for them to come back. And you soon realize that you have to make 45 round trips in order to get the resources that you need. That's a lot. So they said, well, instead of opening 2, let's break this recommendation that the protocol makes and open 4, and then 6, and then 8. In this way, I can parallelize my request to the website. And it's really cool. So domain sharding is a trick where you trick the browser, for example, and you store all your images into images.domain.com, but your main pages are on www.domain.com. Okay? So the browser thinks those are 2 different domains and opens 8 connections on one side and another 8 connections on the other side. What's the typical problem with this is that typically you deploy the same things on the same server. So it's the poor Apache instance in there that it's actually taking responsibility for those 16 connections from a single browser. Imagine CNN.com, millions of browsers, multiplied by 16, it's millions and millions and millions of connections. That's why it's not efficient. So there's another twist to this, that not only the clients want to be fast, but also the servers want to be really fast. So these are 5 examples of large companies that have introduced performance into their way of displaying their own website, and by doing that, they made a lot of money. A few examples here. For example, Shopzilla, it's an online shop and stuff, decreased the load time of their pages from 6 seconds to 1.2. What happened? That by doing that, they got 12% more revenue and 25% more page views. It's 10% revenue. It's for free, just for optimizing the web page. It's a lot of money for them, right? Take here Amazon.com. Amazon.com made a research, and they discovered that for every 100 milliseconds less in rendering the page, their revenue was actually 1% bigger. Now, just to give you a hint of 100 milliseconds, whenever we close the eyelids, like we flicker the eyes, that's 300, 400 milliseconds. Yet, the human brain is able to distinguish 100 milliseconds difference in rendering of the page, and we stay on that side more. We buy more things. So much so that Amazon makes 1% of millions of dollars more revenue just because they shaved off 100 milliseconds. And so forth. I mean, the examples are really, there's many examples. This is now established data. It's not something that I can make it up. Mozilla.org, the final example, they shaved off 2.2 seconds from their main landing page. This converted into 60 million more downloads of the Firefox browser, right? 60 million a year, just for shaving time on your landing page. So what do we learn from this? That better HTTP means more money. It's not just about the technical issue. It's about the business. How many of you here are manager or something that they have a budget, that they can take decision based on money? A few. Okay. So this is important. If you stay on a car that is 20 years old, you're going to pollute the system. Okay. You need to buy a new car. It's old. The HTTP protocol is old. Fortunately, it has been updated. So we had this really old car, 20 years old car, but now we have a new one. So let me dive into a little bit more details about how HTTP2 works. First of all, it's not anymore a textual protocol. It's now a binary protocol. It was based on a previous experiment from Google called the Speedy protocol. But being binary is now much more efficient to generate and parse. Okay, so implementers of the protocol, like for example, I work on the Jetty team, but every server container out there has to create a parser for the HTTP protocol, can do this much more efficiently. And it's based on packet of bytes called frames. And it works in this way. We have a browser, we have a server, and then the browser makes a request and packs the request into a frame called the headers frame. This frame carries the normal HTTP semantic. It carries the method, it carries the URI, it carries the HTTP headers, okay? And then, for example, if it's a post-upload, it can send another frame called the data frame that contains the upload bytes that you want to upload to the server. And now the server can reply exactly in the same way. It sends back a headers frame containing this time the response headers, okay? And it can send multiple data frame containing the resource that you asked. Okay, so for example, if it's a large image, you have a first part of the image, a second part of the image, and so forth and so forth. Okay, multiple data frames coming down. Okay, so how is HTTP2, the ecosystem around HTTP2 changing? Well, HTTP2, the protocol itself doesn't mandate the use of TLS, of SSL, okay? But what happens is that the browsers, implementers, chose to only implement HTTP2 protocol over TLS. Okay, so only if you connect to an HTTPS site, you will be able to use HTTP2 from a browser. All right, and among the ciphers, the cryptographic ciphers that are used to connect to those sites, they chose a very specific subset made of only very strong ciphers. There is a movement of the web and currently of the IETF, which is the committee and the organism that governs the web protocols, to move towards more security in a sense and confidentiality. So they really strongly advocate the use of TLS everywhere. This is not a problem anymore because, for example, there are sites, websites that offer free TLS certificates for your servers. Okay, there's one of the most famous one is called let'sencrypt.com, and it offers free certificates. So you can do it, and it's possible to do it. Plus, I mean, depending on your business, if you're making $1 million like Amazon and Yahoo and so forth, then you can afford to spend a couple of $100 a year to buy a certificate. Making everything TLS could have some problem. For example, in third world countries, there were many providers of internet connectivity were implemented strong and aggressive caching mechanism in order to make the people that are actually using phones or internet connection to spend less. They could do that only if they knew the traffic and say, oh, this user requested this page, let me fetch it and then compress it, and then next time that this page is being fetched, instead of doing the expensive network call to the real website, I'm returning the actual page that I have cached here. So for this particular cases, these problems will be addressed. They're not yet, but they will be addressed. So there are solutions that people is working on for this stuff. However, as I said, the protocol doesn't require TLS. If you're doing, for example, server-to-server communication within your own data center, you can totally use HTTP2 over clear text, so without encryption. One great feature of the HTTP2 protocol is that it's multiplexed, finally, okay? Multiplex versus duplex means this. When I open a physical TCP connection, if it's duplex, like HTTP1 is, I can only make a single request over that connection. And then I have to wait for that connection to return with a response before reusing that connection, okay? That's why browser open multiple connections, because they want it to go parallel. But now with HTTP2, this is not needed anymore, because this is what happens. Okay, I have some problem with okay, this is what happens. The blue pipe is a physical TCP connection. But HTTP2 opens what they are called streams. They are smaller pipes inside the bigger pipe. And this one is a stream that represents a single request and response. Okay? But the cool thing is that I can open multiple ones in the same TCP connection. Okay? Suddenly, one of the problems that was a big problem for HTTP 1.1 and for which there were hacks and there were best practices that we were using, like domain sharding, it's gone. There's no such problem anymore, right? Because in this particular scenario, we can make any number of requests within the same physical TCP connection. We just open a single connection to the server, shove into it as many requests that we want, and they will be answered, okay? We will see a demo about this and how much different this does. So what happens here, for example, I made 3 requests. You see, this one was the first one. It's already going to the server. This one was the last one. But the server could choose to answer this one before the others, because maybe the processing for that request takes less time. And so the others come up when they're ready, right? So this is the final diagram. There's another cool feature on HTTP2, which is header compression. If you're familiar with the HTTP protocol, for example, one common HTTP header is the user agent string. It's a very long string that says what browser you're using, what resolution your screen is, what operative system you're using, and blah, blah, blah. It's a constant. Yet, it gets sent over the network for every single request, okay? Imagine the case that I was shown before, the 400 request website, I think it was Pepsi.com. Imagine that same 100 bytes sent over for 400 times. It's a constant. Come on, we can do better. And this is what we do. In HTTP2, actually the request header are compressed. The first request that is being made to Pepsi.com contains a compressed header, but the second request doesn't even contain those bytes. It just contains a reference to the previous request and say, hey, the second request has this header, and by the way, look here. Just a backtracking reference, okay? 1 byte. That's it. So we went from 100 bytes every time to just 1. It's a 100-time reduction. And link this again to money. You spend money based on the traffic that you're actually making in your cloud or whatever. You're paying for that. Maybe not much, but if you have a very successful website, maybe at the end of the month, that bill is big. And if you can save some, that's a good thing. Another nice feature of HTTP2 is what is called the request prioritization. It's kind of a feature that is now under scrutiny. This was heavily requested by the browser guys because they said, oh, we know that for rendering this page, we need this resource first, but then no, sorry, CSS came down, I changed my mind, now I need this other resource first because I need this for render the page in a faster way. And so we're still looking at how to exploit this feature, but the good thing is that now this feature is in the protocol. We may not be able to exploit at its best today, but tomorrow maybe we could. And if we could, then the performance again of websites will just rise. One of the other coolest features of HTTP2 is what is called HTTP2 push. We're going to see a demo about this as well. But finally, we have realized that HTTP resources are correlated. When I ask for an HTML page, I get down the HTML, but then turns out that for that particular HTML file, I have to fetch a CSS, I have to fetch JavaScript files, I have to fetch images. And therefore, the secondary images, the CSS, the JavaScript, and the images, belong in some way to the primary HTML page, okay? This is natural for us. I mean, it's like, yeah, that's normal. I mean, every page is different. Maybe every page is a different CSS or different JavaScripts that I'm using. But yeah, why is not this in the protocol? Well, it's now possible with HTTP2 to build this kind of relationship. And how does it work? It works in this way. With HTTP 1.1, this is what was happening. We made the request for index.html, one round trip, come back, okay? Then the browser would start parsing the HTML and find, oh, I need a CSS, a JavaScript. And it turns out that parsing the CSS, there was a reference, a URL reference to a background image. So let me do another round trip and get this background image and then back. So in order to render this very simple page, I need 3 round trips, okay? If you are across the ocean, that's 200 milliseconds per round trip, and that's already, 600 milliseconds just to get the resources to create the page, right? And to start thinking about rendering the page. Well, but the server, now that has seen these 4 requests all together in a while, can say, well, you know what? I can build what's called a push cache that correlates these resources together, right? Every time you ask for this guy, probably you're going to need these other guys as well, right? So I can build a push cache, and with HTTP2 and push, what I can get is exactly this. I can make the request for index.html, and then the server say, hey, you know what? This is what you need to render the page. Boom. And push down all the other resources. One single round trip, okay? You have just cut the rendering time of this page by a factor of 3, just because of this feature of the HTTP2 protocol, okay? Remember, less time rendering the page, 100 milliseconds shaved, 1% of your business money better. Are we ready for this? Is this real? Or am I thinking or talking about some experimental things? Well, the thing is that it's already there. How many of you have a Gmail account? Yeah, almost everyone. So you have to realize that none of you was actually speaking the HTTP1 protocol with the Google servers using Gmail since at least 6 years. You are not using HTTP anymore. What you were using Speedy before, now HTTP2, and now there's an even more experimental protocol from Google called Quick. But the key point is that you didn't even know that you were not using HTTP anymore, right? You were using a more efficient protocol, yet for you was totally transparent, okay? So HTTP2 is here. It's implemented in Firefox 34. We are now at 42, I think, 43 maybe. Chrome 38, we're now at 46. Internet Explorer 11. Now, this is the cool thing. We cannot make jokes anymore about Microsoft Internet Explorer because Internet Explorer is now deprecated, and there's Edge now, and 11 and Edge do implement the HTTP2 protocol. So not even Microsoft stayed back on this because they realized the enormous potential of HTTP2. So Twitter, Google, every major website, my company, webtide.com, we run our own website using Jetty, serving HTTP2 pages and with a WordPress backend. So we have PHP from Java on HTTP2 on our website. You can do it too. It's super cool. The Voxed website, the list is growing. I mean, it's like everybody's moving there, and they do it for a reason. Not because it's technically cool, but because it actually means money. So, cool. So, who's convinced now, I want to give this a shot? Come on. Raise, cool, cool. So, can I? I mean, where's the tools? Okay, CURL, Wireshark, they are tools for, network analysis. Now, because HTTP2 is a binary protocol, it's much more difficult to actually see the protocol and what's transporting, right? But these tools help you out. If you go to this page, which is the HTTP2 specifications page on GitHub, you can find 35 more implementation in basically every language. You can find Java, C, C++, Go, Node.js, Erlang, Haskell. Like, name a language, there is probably very little unknown. Your own language probably has an HTTP2 implementation. So we're super cool. What about Java? Well, there's very good news. The first is that there's no change required to your web application archives. Like, you can literally take your WAR that now you deploy on Jetty, Tomcat, Undertow, JBoss, whatever. Take your WAR, take a servlet container that supports HTTP2, drop the WAR after having configured the server container for HTTP2, done. Done. There's nothing else that you can do. So they just work out of the box. The push functionality, for example, is provided by the servers. So you configure the servers to actually provide this functionality, not your web application. So if you go, for example, Undertow has a push functionality mechanism. Jetty, we were the first to provide this push functionality and this particular algorithm, and even at the speedy days. So we know this stuff very well. What do you have to do? Well, maybe you want to remove the old HTTP 1.1x, maybe. They're not needed anymore. The protocol now is efficient for today's web, okay? It's built, designed, and implemented for today's web. The Java case requires JDK 8. The main reason behind this is that HTTP2 requires very strong ciphers that are only available in JDK 8. If you want to run like a pure Java solution, you have to use JDK 8. If you're doing server-to-server clear text HTTP2, you may run on JDK 7, but as far as I know, no implementation on JDK 7 exists, plus JDK 7 is end of life, so stick on JDK 8. Servlet 4.0 will eventually support HTTP2. We have no dates yet for Servlet 0, but as usual, will be backwards compatible. So if you have a Servlet 4 server container, you can deploy your web application, even if you don't use the latest features. But it will be HTTP2 compliant, and it will probably expose an HTTP push API so that you can actually programmatically decide what to push and what not to push. Okay? There's also a lot of activity in the OpenJDK. For example, there are these JEPs, Java Enhancement Proposals, number 110. This proposal is for HTTP2 Client API, finally. I think the JDK right now has 3 different HTTP client implementations, all under the Sun MISC or something, or ComSun something. Finally, this one will bring a nice API based on lambdas and stuff, and HTTP2 compliant as well. So you can, for example, set priorities, receive multiple responses only if you make a single request because of push and so forth. Another, I'm involved in these efforts. Another effort is JEP 244. It's a TLS specific extension that it's required by HTTP2. This is more technical details, but the news or the important news here is that OpenJDK 9 is addressing these little bits and pieces that are required for HTTP2 to happen in JDK 9. So I spoke at another conference with, Jürgen and I spoke with, man, help me out, the chief lead. Yeah, Mark Reynolds, the lead of the Java effort, the runtime and everything, and the Java platform. And he said that basically, if not for Jigsaw, which is the main focus for JDK 9, so the module system, probably HTTP2 would have been the second most important feature to enter JDK 9. So it is going to arrive. In the Java world, well, Jetty, we have a server and client. We are live on our website. Netty has an HTTP2 implementation. Undertow has an HTTP2 implementation. OKHTTP is a client for Android that you can use. It runs on the Android API, so it's still JDK 7 compliant. So whatever solution, whatever application you want to do, you have the possibility to do it. This is an example about Jetty. We have a high-level HTTP client class, which is typically used in this way. You just instantiate the class and then use the API. Okay? You want to make a GET request, you want to make a POST request, and so forth. Well, this is by default HTTP 1.1. If you want to use HTTP 2, this is the only change that you need to do to your configuration code. Especially because you say, okay, I want an HTTP client, but I want to use the transport of this HTTP semantic over HTTP 2, right? So I want to do a get of this particular resource. I can translate my will of getting this resource either into HTTP 1.1 protocol, into the wire, or I can say, well, the same request, I want to translate it into an HTTP 2 binary protocol on the wire. Okay, send it back, get the response back, and call me when you're done. This is the recommended deployment that we suggest. Clients, HAProxy, which is a very efficient load balancer written in C, which can do TLS offloading, and so it's basically a solution. A typical solution would have been, clients, Apache in the front, Tomcat in the back, right? Typical solution. Instead of doing that, we're doing this. We replace Apache in the front with HAProxy, which can also do load balancing, like HAProxy is like Apache can with a specific module. And then, rather than speaking HTTP 1.1 with the backend or AJP or whatever other protocol, we speak HTTP 2 clear text on the backend. Jetty can do that. I think also Undertow can do that. So this is going to be a very efficient setup, because when Jetty decides with its push cache that it has to push resources, then these information can go from here to here directly to the client, and the browser can take advantage of push, right? So you have to update not only the protocol, you have to update the architecture, the way you deploy things. Think about different way of doing the same things over. You don't need Apache in the front. It's not an asynchronous service anymore. Now Apache is being kind of replaced by Nginx. Yeah, that's also cool, but Nginx cannot speak HTTP 2 to the backend yet. So that's why we're suggesting this solution here. Ready for a demo? Let's pray the demo gods that everything goes fine. And let me see where I am. OK, so this is a simple page where I have two links to different ports on Jetty behind. So when I click on these links, we go to the same page. The page that shows up is formed by other 24 smaller images that compose a bigger image. Okay? This is to simulate a typical web page where I request for a resource, but then I actually, when the main resource comes back, I have to make multiple other resources. Remember the 95 for CNN.com? Here, I'm just simulating 24 other resources. Okay? There's a catch, though, that because the localhost interface on my laptop is so fast, we wouldn't see any effect. So I slowed it down in order to simulate a 200 millisecond delay in round trip. Okay, so imagine you're basically calling a server in the United States from Europe. Okay, so let me click here and see what happens. Okay, and click. Okay, so this page was rendered in, a couple of seconds, maybe 1.5 seconds, something like that. Have you seen like the very first images that probably was this one beat here came down, then a second one was coming down slower, and then the other one were coming up faster. That's a feature of the TCP protocol called slow start. Every time you open a TCP connection, that connection is cold and doesn't transfer data at its maximum speed. You have to do many round trips back and forth in order to warm up that single connection, and then that connection is kind of warmed up, so much so that if now refresh this page, now probably now the browser has closed that connection because it was idle, but let's try to refresh it. Okay, still slow, but now we refresh it again without waiting the idle timeout. As you can see, it's, now the connection is slightly faster because the connection is being warmed up, okay? Okay, enough about HTTP 1. Let's go back. And now let's try HTTP 2. Click. You see the difference? This is much, much better, okay? And, well, there's a surprise now. Jerry, which is in the back, didn't know that those 24 resources was correlated. It was this particular request that told Jerry, hey, I'm making you a request for this HTML page, but then look, there are 24 images correlated to this, right? So now Jerry has this information, and if I refresh the page, click, oops, we don't see the compositing of the bigger image anymore, right? This is, click, did I click? Click. You don't see it anymore, okay? Now, this is what makes you money, okay? This is the big difference between HTTP 1 and HTTP 2, all right? And because at the other session, the performance session from the Dynatrace guys, this was mentioned, let me open, man, Control K, Control J, what is this? Sorry. Okay, so if I am on this page and I do Control J, no, it's not Control J anymore. Control Shift J, thank you. Let me try it again. Oh, no, it's Control Shift J. Okay, so let me go to the network here, and let me go back to the HTTP 1. Okay, and let's take a look at the profile here. What's going on? Okay. Okay. Okay, so what's going on here? You see that, well, this is not well ordered, but you see there is a kind of a waterfall, right? So it was the first request was made, okay, and then other requests were being made at different times. And the reason they were made at different times was that Chrome was actually opening different connections, okay, but then only opened 6. And then it could only make 6 requests at a certain time. So we get these responses back, okay, but then you can see here there is a gap, and after these guys returned, then that's when the other resources was actually sent over the network. So this set of resources here had to wait the previous one to return. And then the next set, this last 3 here, had to wait these other 6 in order for them to free up the connection and then actually be sent over the network. So that's where you're spending your time in HTTP 1. Now if we go back to HTTP 2, and see the same, oops, this is what happened. That we made the first request, but then Jerry said, oh, you're going to need these 24 images. So basically all the other 24 requests are in the same line here. There's no time spent, because those all 24 requests could have been shoved immediately into the same TCP connection, send it over to the server, and the server could just say, well, I've already sent you this. Thank you, bye. And so they're already down, so they're not needed anymore. So HTTP 2 is super cool. And I've shown you the difference in timing and perception even, right? Even if I refresh the HTTP 1.1, you can see the images actually composing the bigger one. But with HTTP 2, after a single refresh, you don't even see flickering this thing, right? Big difference. All right, let's go back to the presentation. And of course, I am at the very initial page. Let's move on. Okay, conclusions. So, the good thing about HTTP 2 is no changes for web developers, okay? The developers of web application, maybe they just need to pay less attention to the hacks that they were doing before, but you know, practically they do nothing. They just develop their application like they did before, done. If you're moving to JDK 9, there is a possibility for framework implementers like Spring or whatever to implement push functionality and offer API to your application. You can leverage those if you will in the future. However, deployers, so DevOps, SysOps, need to pay a little bit more attention. First of all, they need to be prepared to TLS. They need to move their website to SSL. So they need to buy the certificate. They have to put in process something in their company, a process that renews the certificates every year or every 2 years. So this is not a big deal. For example, let'sencrypt.com does this for you. Well, it offers you tools to do that in an automatic way. You need to upgrade your server container. So if you're using a server container that doesn't support HTTP2, please do upgrade your container, because there exist containers that already offer this feature since months, and I would say now even years, right? So we are ready for this already. Jerry 9.3, as I said, Undertow, and so forth. And you need to take a look at your network infrastructure. Maybe ditch Apache, maybe replace Apache, find a way to make this consistent and have HTTP in all the steps of your network infrastructure, okay? Load balancer, look at load balancers, you know, F5, whatever you have. They are working towards HTTP2, of course, because it's very important to them too, but they're not there yet. So, you know, you have to look at the specs, be very careful in what you choose, what you buy, and then if you already have these guys, pick up your phone, call your provider of network infrastructure and say, hey, do you support HTTP2 because it gives me money? So if you don't and you're a blocker for me, that's not good. And you know, I'm gonna move to someone else that does. So, you know, push for this, because the web is in desperate need of a better HTTP, and the faster we get this out, the better. So I really want you, I'm almost done, but there's one thing that I really would like you to get out of this presentation is, first of all, is the curiosity to go and explore HTTP2 and see what options you have in order to bring HTTP2 to your company, to your deployment and day-to-day activity. The other thing is that this is not only a technical thing, but HTTP2 makes you money. So it's also a business thing. Thank you. I don't know the timing, but there are questions already I can see. I think there's a mic here. Is the mic on? But otherwise, if you can shout, I'll repeat. So the question is whether a solution based on PHP, so Apache plus PHP, and the stuff already support HTTP2, is that right? Okay, so the answer is, I would say yes. For example, Nginx can call PHP and offer HTTP2 in the front. I'm not totally sure about Apache, but I think that's possible as well. You install mod HTTP2 on Apache and then mod PHP to talk to PHP. We can do this with Jerry too. So for example, you can have Jerry talking to WordPress. Our website is built in this way. So yes, it's possible. Yes. So how the client knows that the server supports HTTP2? The primary way, that's the way the browser uses, is to use the TLS extension that I showed you briefly before. So basically what happens is this: every time a TLS connection is being established to the server, the client sends a small extension in the first TLS message to the server that says, I can speak HTTP2, HTTP1, and that's it, basically, right? So I can speak these two protocols. The server says, oh, I understand this extension because I support HTTP2, but you know, maybe I'm not configured properly for HTTP2, so I can only speak HTTP1. So it sends back to the client a response message. This is still part of the TLS protocol connection establishment. And sending back to the client what is the protocol that the server has chosen to speak with the client. At that point, the client can see the response from the server, finish the TLS handshake, and then going back to that response and say, oh, what protocol that the server told me to speak? Oh, it's HTTP2. Okay, let me try HTTP2 first. And then the communication goes on in this way. So this is the typical way the browser used to implement this. And if we go for a second to the browser, you can see there's this small extension here. You see it's a bolt. It's a blue bolt here. If I hover over this bolt here, it says HTTP2 enabled. So it actually, this small extension on the browser is able to tell me whether this page was actually displayed using HTTP2, yes or no. If you go to google.com, Facebook, blah, 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 then you'll see, and you have this extension enabled, you can see what you're actually speaking. Say it again, sorry? Okay, over non-TLS connection, okay, browsers cannot, do not support yet this, but if you're doing server to server, you have two choices. The first one is, I know that that particular server on that particular port speaks HTTP2. Okay, that's the first thing that you can do. The second thing is you also use the TLS extension on the client. So you actually open a TLS connection to the server. For example, in the recommended deployment that I suggested you, let me go there so that here, yeah. HAProxy is offloading TLS, okay? So the decryption and encryption happens here. So HAProxy speaks to Jetty using clear text HTTP2, okay? Well, I know here, I have configured HAProxy to connect to a particular port in Jetty that I know that that particular port can speak HTTP2 clear text. So basically, this guy sends bytes to the backend, and it just happens that the backend understands those bytes and responds properly. So that's the other thing. There is a second mechanism, which, as I said, is not implemented yet, but we support it in Jetty. It's called upgrade. So the client can send a special request to the server using HTTP1.1, but in that particular request, the client can say, I would like to upgrade this connection to HTTP2. The server replies to that request with a special answer. If the answer is, sorry, I don't understand HTTP2, so I don't know, let's continue speak HTTP1, the client says, okay, let's continue HTTP1. But if the server responds with a very particular response that says that it can support HTTP2, then at that point, the client can start speaking HTTP2 immediately to the server. It requires one more round trip because they have to agree on what language to speak, but it is possible. So, for example, you can do this with the Jetty client, but only version 9.4, which is not out yet. So we're working on it. But you know, there is possibility to do that. The server, Jetty the server, already supports this kind of upgrade. So if you have a client, for example, curl, can do this upgrade request, and Jetty can actually reply properly, and then they start speaking HTTP2 clear text, no problem. Yes? Are there any implementations, sorry? Okay, so the question is, are there any implementation to make more money in the Microsoft server? Is that correct? I don't know. Yes.
How is the push cache handled from a security perspective so that it doesn't push you confidential information?
Okay, so the question is how the push cache works from the security point of view and pushing you down information that you don't want. I guess that's the question, or confidential information. Okay, so the answer to that is that you have to imagine that those requests would be made anyway by the client. So the browser, in order to render that particular page, can say, for example, I need this JavaScript, I need the CSS, otherwise it cannot render the page. So if you don't push those, then the client would make the request for those, right? The second thing is that in Jetty, in particular, I can speak for Jetty, but the cache mechanism that you have is completely customizable. So for example, you can say only cache JavaScript files. You can add your own logic on top of this, and you can say, for example, only cache JavaScript file for 30 seconds, or do not cache all the URIs that start with /secure, or any logic that you want. So you have full control on this. We offer a default implementation that does, the basic things, but it's totally customizable by you, and so your power to you. I mean, you can do whatever you want. Yes. Yes. Okay, so the question is how HTTP2 relates to WebSocket, whether the protocol is stateful or stateless, and so forth. So the two, like before, like HTTP1 and WebSocket, they are different protocol for different purposes. WebSocket was primarily built for pushing from the server to the client messages, not resources, as in this case, okay? HTTP2 has been designed not to push generic content from a server to a client, but to push correlated resources that belong to the HTTP space, okay? So JavaScript, CSS, images, and so forth. So the two are still separated. So if you have an application that uses WebSocket, you're going to open two different connections, one HTTP2 to download the resources, and one for WebSocket to do the messaging over the web. There are efforts to try to merge those two and have actually HTTP2 also transport WebSocket messages, but that's, it's been a mess, but this. No, it was scheduled for this for consideration. Actually, the HTTP2 protocol could have been much better if we just concentrated in a transport mechanism rather than a semantically transport mechanism. But it hasn't been done. There were timing constraints, there were fierce battles in the expert group, which we were part of, and many very super smart people about protocols and shaping the design of the protocols, not having common ground and coming to a compromise. So basically what happened was that, okay, let's take this out of the charter for this particular protocol. So they're still separated so far. But as I said, there are already rumors about HTTP3, and HTTP3 could be a totally different protocol made in a way that it builds on the very good features that we had in HTTP2, plus taking care of WebSocket as well, which would be super cool. Absolutely. Regarding stateless versus stateful, the high-level HTTP semantic is still stateless, which means, for example, that you have to send the session cookie or cookies in general, you have to send them over and over for every request, all right? The cool thing is that instead of sending the long cookie for every request, now every subsequent request just send a back pointer to that, so you're saving a lot of space. However, at the protocol level, it is stateful in the sense that, for example, in order to remember that there was a previous request and that previous request had a cookie, so the second request will actually backtrack that you have to keep a context per connection. So we haven't done measurement of this for memory consumption on the server. The cool thing is that the performance benefit that you get in actual page rendering is so overwhelming that probably nobody has yet looked into how much more memory do I spend for an HTTP connection. And the other thing is that with HTTP2, you only open one. So that's one file descriptor on the server, one socket in the Java world, while before, with HTTP 1.1, you could open like 20, 400, like numbers that do not make any sense. So even if it had much memory consumption, more memory consumption, it would probably be dwarfed by the fact that the protocol is much better designed. You had another question? Say louder. Correct. Correct, correct. There is one stateful TCP connection, and let me say there is, remember the pipe, the blue pipe with the green pipes inside? Well, basically there is a hidden green pipe for stream 0 that it's basically always open. That one is the one that keeps the HTTP2 statefulness. All the rest, the normal requests, are stateful. And just to give you an idea, the client configuration for how many requests can be sent at the same time over that single TCP connection is 1,000. Okay, so problem gone. It's like you don't have any problem with domain sharding anymore. Solved. All right. So the question is whether there is any benefit for REST APIs to do this. Well, no, not much, let me say in this way, because typically what you return in a REST API, the content that you return is not a resource, is more data. So in that particular sense, HTTP2 has not been designed to support this kind of things. And when you make a request, like a REST call that returns JSON, that request in itself is self-contained. I mean, when the JSON comes back to the client, you're not parsing the JSON, and because of that, making other requests like you would do with HTML. If you do that, then you can also exploit this feature. However, the browser is likely not caching this information for you. So imagine I'm making a request for JSON data, right? So the content type is application/JSON. And when this resource comes down, if the server pushes another JSON, the browser will look at the responses and say, oh, this was the request that I just made. I got a second request, a second response that seems to be correlated to the other one, but it's application JSON. Should I really cache it? Maybe no, I just discard it, right? So the browser are also very conservative in what they're allowed to cache for the specific mechanism that HTTP2 offers. So I don't think they're going to cache JSON data, JSON content types. Say it louder, sorry. Compression. Yes, that's totally available. Again, that's totally available. Yes, the server could say, this is your JSON, and by the way, I have gzipped it. So it sends back to the client. The client can just say, oh, it's gzipped, content encoding gzip, fine. Let me just explode it, done. So. A good question. So the question is the server risking to sending to the client data that maybe the client already has or that the client doesn't need because it's already in the cache? Yes, there is this risk. However, the HTTP2 protocol has a mechanism to cancel request, which was not available in HTTP 1.1. So what happens is this, that the server, before sending the data down to the client, sends a frame to the client telling, I'm going to send you down this information. And the client can say, oh, you're going to send, but I already have it. Cancel that. Now, it could happen that the server has already sent the data. Maybe it's a very small image. So it's already in flight going to the client, right? So by the moment the client decides that it doesn't need it and cancel it, it's already gone, right? This doesn't matter much because remember the key point is that nowadays we have very fast connections, but the problem that is killing us is not the speed of the connection, is the latency going from here to across the ocean and back and doing multiple things, multiple of these round trips, right? So yeah, I'm downloading you more data, but in just one round trip. And you know, typically this is going to be better. But there's a good news about this. So the good news is that the client, imagine the client could make a request and tell the server what has in its cache about that particular request, okay? Say, for example, I have the JavaScript that is associated with this resource, and the expiration date is this one, okay? Now, this information could be standardized in an HTTP header sent to the server. The server could look at that header and say, oh, it has this, this, and that. I'm not going to push it. So this is still experimental work, but the cool thing is that the protocol itself is open to this extension and it is allowed to do that. So the future will be even better. Right now we are at the very beginning, we are experimenting with these things, but there is so much potential. So thank you for listening. I think we're done. Thank you.